Hello and welcome to Math on the Go. This is just going to be an introduction to algebra in my algebra series. So algebra is a method of written calculation, and unlike many other subjects, it requires practice. Think of it like an instrument or a sport or even cooking. The more you practice it, the better you're going to get. So part of the thing that scares people is there are letters in our numbers. Why the heck are my ABCs and my 1, 2, 3s? Well, in algebra, they're used as placeholders. Basically, we imitate the rules of numbers with letters. It's a way to show that the rule will be true for any number you plug in. So, for example, we can summarize the rules of dividing fractions without including numbers to show that this rule holds for all numbers. So say we have A over C plus B over C. That would equal A plus B over C. So what this is saying is that we need a common denominator to add, and then we add our numerators together. So if we had A over C plus B over D, we would need to get C and D in the denominator for both of these fractions. So we would multiply the left side by D over D and the right side by C over C. We would get AD over CD plus BC over CD. Now that becomes AD plus BC over CD. So moving on, there's 4 operations in arithmetic. The first operation is addition, or the sum. And that is A plus B, with the operation being the plus sign. The second operation that we have is subtraction, or difference. So that would be A minus B, with the operation being the minus sign. The next operation we have is multiplication, or the product. So we would have A times B with the little dot meaning multiply, or we could write it as AB, or we could write it as A times B using parenthesis. And then our fourth is division, or quotient. So that would be A over B. So when we're talking about algebra, we're no longer going to be using that for multiplication or that for division. These two symbols are no longer used. Not used in algebra or in any of the sciences. So a little bit more with words. The sum would be used with an expression such as A plus B minus C plus D. So I know that I stated that the sum is also addition. But even though there's a minus sign in this expression, we still refer to it as a sum of the terms because we're still doing all these terms together. So we want to know what the sum is, all of it together. So this is the sum of terms Next up, we'll deal with the product of terms. Now, the product of terms is when we have something such as A times B times C times D, or A, B, C, D, or A times B times C times D. All those mean the same thing, and they are the product of terms. So this is the product of 4 different factors. And the word factors signifies that you're going to multiply. So let's write something. We'll do 2a plus 4bc minus 2a parenthesis b plus c. So what we're going to do here is let's talk about how many terms and how many factors each term has. So this has 3 terms altogether. 2a is 2 times a, so there are 2 factors in 2a. Factor 1 and factor 2. In 4bc, we have 4 times b times c. So that has 3 factors, 1, 2, and 3. And then the third term, that is 2 times a times b plus c. So it also has 3 factors. 2, a, and then b plus c. The parenthesis around the b plus c tells us that we should treat whatever is inside as one number. So if we had 2 times a times 2 plus 3, that would become 2 times a times 5. So see, that's where the 3 factors come from. Moving on, let's discuss powers and exponents. When all the factors are equal, such as 2 times 2 times 2, we call the product a power of the factor. A times a would be called a squared. The small 2 above the a is called an exponent. Which signifies how many times to repeat the factor or the multiplication of a. So these 2 things are equal. A times a is the same as a squared, or a times a times a times a would be the same as a to the 4th. Now that we have some of the basics down, we should discuss the order of operations, which I have done a shorter video on, but this will be a little more in depth. The order of operations is the order in which we simplify an expression or solve an equation. And as I said before, we do not use the x to signify multiplication, and we do not use this symbol, which is called an obelisk. I think I'm pronouncing that right, but we don't use those in algebra. So yeah, we won't see anything like 6 divided by 4 times 3 plus 5. The way you would see that written in an algebra class, calculus class, or science classes, it would be 6 over 4 times 3 plus 5, and then that would be solved like that. When it's written like this, it gets a little bit confusing, and that's where those online math problems seem to stump a lot of people. So let's get to the basics of order of operations. Let's break it down. So the first thing we're going to do is we're going to evaluate the parenthesis. So what that means is that the first thing we're going to look for is anything inside of parentheses. And when you find them, do whatever you can inside of these parentheses first before you move on. If there are multiple sets of parentheses in your problem, do all of them first. Okay? So the second step is we will evaluate exponents. So after we do the parentheses, we'll look for any exponents, and we will solve those next. The third step is multiply and divide. These two are basically equal in this situation, but I always kind of look at it as do those from left to right. Okay, and the fourth step would be addition and subtraction. These two we definitely want to evaluate from left to right as we're working on a problem. But we'll get into that when I do some examples here. A lot of people remember this as PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. Abbreviations, mnemonics, or whatever you want to call it, they kind of get a little confusing, so we won't really focus on that. But if it helps you remember it, then that's perfectly fine. So let's move on to some examples. So let's say we have 8 plus 4 times 3 plus 1 squared. Now remember, we do parentheses first. So we have our 8 plus 4, then we have our parentheses, 3 plus 1 is 4 squared. After our parentheses, we look at our exponents. We have 4 squared, so we have 8 plus 4, I'll use the little dot for multiplication, 4 times 2, or 4 squared is 16. Now, we look for any multiplication or division. We have 4 times 16, which is 64, so 8 plus 64. Now we're left with just the 8 plus 64, which is 72. And that's using order of operations. We came up with that. I'll show you that you can put this into a calculator and get the same exact answer because a calculator uses these rules to solve problems. Now, let's have a look at a problem with just addition and subtraction. We'll have 50 minus 10 plus 3. Not overly complicated looking, but this is where the working from left to right really comes in handy. So if we work left to right, 50 minus 10 is 40 plus 3 gives us 43. All right, let's get a little more complicated. Let's do 8 plus 7 over 5 minus 2. Now, I know what you might be thinking. There's division, addition, and subtraction. How do you divide first before doing addition or subtraction? Well, when you have something like this, you have to consider the numerator is in parenthesis and the denominator is also in parenthesis. So really what you're going to do is we're going to solve the numerator and solve the denominator, and then we're going to divide. So what we end up with is 15 on the top in the numerator, 3 in the denominator, and then we can reduce this. 3 goes into 15 5 times. Again, something like this can be punched into your calculator, and when you do put one of these in your calculator, you would surround the numerator in parentheses, put in your division symbol, open up parentheses, put in your denominator, close parenthesis. So that is what you have to think of, but you're not always going to have them given to you in parentheses. So you would just get 8 plus 7 over 5 minus 2, and then have to solve from there. Adding parentheses helps, then do it. If it doesn't, then you don't have to worry about it. Just know that you want to do your addition on the top, your subtraction on the bottom, and then do your division. All right, let's put some multiplication in our fractions. We'll do 6 times 3 over 2. In this case, there's 2 different ways we could do this. So I'll write it a second time down here. 6 times 3 over 2. First way, we're going to multiply 6 times 3, which gives us 18 over 2. And then we're going to divide. 18 divided by 2 equals 9. Now, one of my favorite ways to do one of these, because it makes you have to work with smaller numbers, is since we have multiplication in the numerator, let's reduce. We can reduce. So this 2 goes into 6 3 times. So that leaves us with just 3 times 3. We know 3 times 3 equals 9. Both of these methods result in the same answer, but like I said, it's nice to reduce your fraction down so that, you're working with smaller numbers. All right, let's play a little bit more around with our order of operations. We've got 6 plus 2 times 3 minus 5 minus 4. Okay, so as usual, we do parentheses first. We got our 6 plus 2, 3 minus 5 is negative 2. I like putting in parentheses for my multiplication. That's me. You can use the dot if you want. So now let's look at it. We have addition, we have subtraction, and we have multiplication. So we're going to do multiplication next since there's no exponents and there's no division. So we have 6. Positive 2 times a negative 2 gives you a negative 4 minus 4. Now we just have nothing but subtraction, so let's just work left to right. 6 minus 4 is 2 minus 4. And then 2 minus 4 equals negative 2. All right, let's do 4 plus 5 in parentheses times 8 minus 5. Okay, so like I said, we're going to do what's in parentheses first. We have 2 sets of parentheses, so we'll just reduce both, or not reduce, but we'll do what's inside of both the parentheses before we do the multiplication. So here we have 4 plus 5 is 9, and we have 8 minus 5 is 3 times 3. 9 times 3 is 27. Let's do something else a little crazy here. We'll do 3 plus 3 times 2 squared over 2 plus 4 times 2 squared. Okay? So remember, this is all in parentheses, like that. So let's just work on the numerator first. So let's think about it. We've got 2 squared, which is 4. We have 4 times 3, which is 12, plus 3, which is 15. So that's our numerator. Now in the denominator, we have 2 squared, which is 4, times 4 equals 16, plus we got our 2, plus 2, which is 18. Now we can reduce this. 3 goes into both of these numbers. 3 goes into 15 5 times. 3 goes into 18 6 times. So our final answer is 5/6. So now that we've covered the order of operations, let's discuss variables. Variables are ABCs that we find in our 1, 2, 3s that I mentioned. You know, there are X, Y, Z, or our A, B, C, or our L, M, N, O, P. You know the alphabet. When the alphabet gets into our numbers and our math, that's our variables. Consider the variable to be a blank or an empty number. It could be a whole number, a fraction, a decimal, a positive, a negative, whatever. It can be any kind of number you want it to be. Numerical numbers, such as our 1, 2, 3, 4, etc., those are constants because they will never change. They're constantly the same value. So we're going to have a look at a few examples of our variables where our x is a number and we're solving for y. So let's look at the equation y equals 3x plus 2. Okay, so when x equals 0, we'll put this 0 in for x. So y equals 3 times 0 plus 2. Well, 3 times 0 is 0 plus 2 equals 2. So y equals 2. Let's do when x equals 1. Again, we'll put 1 in for x. Y equals 3 times 1 plus 2. So y equals, well, 3 times 1 is 3, plus 2 is 5. When x equals 2, we have y equals 3 times 2 plus 2. So y equals, well, 3 times 2 is 6, plus 2 is 8. So y equals 8. And you could just keep doing that with any number you want. When x equals 100, we have y equals 3 times 100 plus 2. Well, 100 times 3 is 300, plus 2 is 302. So that's, just a little bit of work with variables, and when you have x and you're solving for y, this is where it comes in handy, stuff like this. Now let's go over a little bit of wording that you're going to come across in math. You see a lot of this kind of wording used in word problems, and I know people hate word problems. I'm not even a huge fan of word problems, but they're just something you're going to have to get used to if you take math classes. Any math classes, you're going to have to do them. So if we have 2 times a number, let's see, 2 times a number. Well, let's think about that. 2 times a number. We don't know what the number is, so it's got to be a variable. So it's got to be 2 times a. Second one, let's think about 2 more than a number. Well, 2 more than a number. Well, what does that mean? We have a number and we have 2 more. If we're having more, we're adding. So 2 more than a number is a plus 2. Do 6 less than a number. 6 less. Okay, so we have 6 less than a number. So we have a number, let's call it a, and we have 6 less of them. A minus 6. That would be 6 less than a number. All right. Let's do fourth one, 6 minus a number. 6 minus a number. Okay, this is kind of similar to the one above, but we're minusing a number. So we have 6 minus a number. 6 minus a. Okay, let's have a number repeated as a factor. Well, this is basically saying we have, a factor 4 times. So basically what this is saying is we have a number repeated as a factor 4 times. So we have a number 4 times as a factor, which means multiplication. So we have a times a times a times a. So we have a times a times a times a, which is also the same as saying a to the 4th power. All right. So that's 5 of these. Let's do a few more just to get some wording down. The sum of 3 consecutive whole numbers So an example of that would be 2 plus 3 plus 4. That's the sum, addition, of 3 numbers. We got 3 consecutive numbers, which means it would be all in a row. So if it was 4, 5, 6, that would work. 7, 8, 9, that would work. So the sum of 3 consecutive whole numbers is 2 plus 3 plus 4. And the way you'd write that using variables, you'd have a plus 1 plus a plus 2. All right, let's work on a 7th one here. We have 4 less than twice a number. Okay, 4 less than twice a number. Twice a number means that we're going to multiply times by 2. So we'll have 2a, and we have 4 less, so we have 2a minus 4. 4 less than twice a number. And let's also look at 1 more than 4 times a number. So let's look at this. We have 1 more, and we also have 4 times a number. So 4 times a number, but 1 more. 4a plus 1 is the same as 1 more than 4 times a number. So there's a little bit of playing around with wording and putting them into expressions. Now I keep using the word expression, and expressions don't have an equal sign. Expression is just, these are expressions. If I were to say it's a statement, then it would have an equal sign. So let's say you have the sum of 2 numbers is 18. The sum of 2 numbers is 18. Okay, the sum of 2 numbers. Well, what are these 2 numbers? I don't know. They're variables. So we'll have a plus b, that's the sum of 2 numbers, is 18. that is an algebraic state. So the difference of two numbers is 18. So the difference is subtraction. What are the two numbers? We don't know. They're the variables. So A minus B equals 18. The product of two numbers is 18. Again, we don't know what the two numbers are. There are variables, so A times B equals 18. These are all algebraic statements because they have the equal sign. The equal sign is your verb in math language, which makes a statement. It turns it into a complete sentence instead of just saying A plus B, which is just an expression. Twice the product of two numbers is 20. So the product of two numbers, or twice the product of two numbers. So we have our two numbers, A times B, but twice that, 2 times A times B equals 20. So our statement of twice the product of two numbers is 20. Twice the product of two numbers is 20. The quotient of two numbers is equal to the sum of those two numbers. So what is that going to look like? The quotient, that means we're dividing, two numbers, our variables, is equal to the sum of those two numbers. So we have two variables, A and B again, and it's the quotient of them. So we put A over B, A divided by B, is equal to the sum of those two numbers. Well, that'd be A plus B. All right, the final bit of this video, I'm going to briefly just throw out the word formulas. A formula is an algebraic rule for evaluating some quantity. Formulas are statements. They equal something. So the first one we'll talk about is the formula for a rectangle. There's your rectangle. And we are going to talk about the area of the rectangle. We have our base, we have our height. And to find the area, which is all of this inside, all of that is our area. So we want to find our area. To do that, we do base times height. So that is our formula to find the area of a rectangle. Same works for a square. A square has 4 equal sides, so the base and the height are going to be the same. So your area would equal A times A, or area equals A squared. Now, there's also the perimeter. The perimeter of a rectangle, perimeter equals 2 times the base plus 2 times the height. So basically what you're doing with perimeter is 2 times the base. We got the base here, and then consider this also the base. So we have 2 bases and we have 2 heights. the perimeter is basically adding all 4 sides together, but we multiply just to make it a little bit quicker and easier. So let's say that we have a base equal to 3 and a height equal to 4. So for area, of this, we would have our base times height, which would be 3 times 4, which would equal 12. Okay, now using these same numbers, base equals 3, height equals 4, let's find the perimeter. Okay, so we'll just plug in the B, or the 3 for B and the 4 for H. P equals 2 times 3 plus 2 times 4, which equals 2 times 3 is 6, plus 2 times 4 is 8, which equals 14. And that's the perimeter of a rectangle with a base of 3 and a height of 4. So I'm not going to go any further into formulas. We'll get more into that in later videos. But for now, I just wanted to quickly touch on a few of the major things that we'll be hitting up later in this series. So this has been my introduction to my algebra course. I hope to get more videos up in the near future as time permits me to do these longer videos. I hope you enjoyed, and if you did, please like and subscribe to be updated when new videos are posted. And thanks a lot for watching.